Okay, so you don't have to write this part down in your notes, but do you remember how to do a problem like this? Like when there's x's and y's throughout, like how we find the derivative? What do you have to remember to do?
Would it be like 3x squared plus 3y squared times y prime?
Yep. The times y prime is the thing you got to remember. So when we're taking the derivative with respect to x, anytime we get to a variable that's not x, you have to do the chain rule. So we're going to be doing the derivative with respect to time. So t is going to be the variable, and t is not going to be in any of the equations pretty much. So after every variable, you're going to have to do times like dx dt or times dy dt. So that's the only reason I have this here, is just to remind ourselves about that chain rule. These steps right here are actually also in your homework packet, so you don't even have to write these steps down. Related rates are word problems, so basically a lot of these steps are the same for every word problem. First, read the problem, then identify and name the variables, draw a picture. We're going to draw a picture for most of these. Determine what you have and what you want. Find an equation that relates the variables. Plug in any constant. So this is the thing that's kind of special for related rates, is anything that doesn't change in the problem you plug in first, then you take the derivative and solve for whatever else you're trying to find. Okay, this is not in your packet. If you want to take a picture of this real quick, these are like some helpful hints for doing these problems. So rate means a derivative with respect to time. We're not going to use the y prime notation because it's going to get a little confusing. So anytime you have a variable, we're going to use like dA dt instead of a prime. I already said this. Remember, how fast is a speed, which is positive. And if it says at what rate, our answer could be positive or negative. Okay, so here's our first problem. Do you need more of the sheets? Yeah. They're on top of that bookshelf back there. All right, how fast is the radius of a spherical soap bubble changing when you blow air into it at a rate of 10 centimeters cubed per second? Oh, sorry. Okay, so let's draw a sphere. Here's a circle. I'm trying to make it look three-dimensional. So imagine we're blowing air into a bubble. What numbers did they give me? They gave me a 10 centimeters cubed per second. When you see centimeters cubed, what does that make you think? Volume. So since this is a volume per second, this is a dV dt. This is a rate at which the volume is changing. So I'm going to label that dV dt. And then radius is 1 centimeter. I'm just going to write r equals 1. That's not a rate. That's just the radius is 1 centimeter. All right, so now we need to come up with an equation that relates these things. So I saw volume and I see a sphere. Do you remember the formula for volume of a sphere? Yep, 4/3. So 4/3 pi r cubed. Just so you know, on the AP exam, they don't give you a formula sheet, but on these problems, they usually like embed the formula in there so you don't have to memorize. Okay, so the next thing we're going to do is decide if anything is not changing in the problem and plug those numbers in next. So we have our sphere. Here's the variables. Volume. Is the volume changing of the sphere? It's getting bigger, so yeah. What about the radius? Would the radius of the sphere be getting bigger? Yeah, so nothing is staying the same, so I can't plug in any numbers yet. Now we take the derivative. So the derivative of v is just dv dt. Over here, the derivative of 4/3 pi r cubed, we're going to do our power rule, so bring down the 3. So that would be 4 pi r squared. And then our chain rule again with the r would be dr dt.
And why do you do it dr dt again?
Every time we take the derivative, we're doing it with respect to time. Since neither of these are time, then a chain rule kind of comes out, kind of like the y prime thing. All right, let's plug in what we know now. Do we know what dv dt was?
But where did the 3 go?
Oh, because I did 4/3 times 3, the power rule. So bring down the 3 and multiply it, and then subtract it by 1. All right, so did we know? Yeah, dv dt was 10. 4 pi. R was 1. And we're solving for dr dt. So how would I get dr dt by itself?
Divide by 4.
Yeah, just divide by 4 pi. So 10 over 4 pi. This is a calculator unit, so if you want, you can type that in your calculator. You could make it 5 over 2 pi. I'm just going to leave it like that. I don't even care about typing in the calculator. So we have our answer, we need units. So we're talking about how fast the radius is changing. What were the units of the radius? Centimeters. So since this is a rate, it's going to be centimeters per second.
Would you have to simplify it?
No. You can leave it just like that. All right, here's the next one. How fast does the water level drop when a cylindrical tank with radius of 10 centimeters is drained at the rate of 3 centimeters cubed per second? All right, what picture do you think I should draw?
So
A cylinder. Draw a cylinder. All right, and we have water inside the cylinder. So here's the water. And it's draining. It says the water level drops. So whatever this is, I'll call this H for height of water. And that's decreasing. The radius is 10 centimeters. So from here over, that's 10. And 3 centimeters cubed per second, what do you think this is? Cubed, what is that telling me? Volume. And since it's per second, this is going to be a dV dt. Okay, so I think we need the volume of a cylinder formula. Anyone remember that? No. I want to take a stab at it. Pi r squared h. That's the volume of a cylinder. Okay, so now we need to think, is anything not changing in the problem? And be careful, we're actually not talking about the cylinder itself. We're talking about this water. So think about the water. Is the height of the water changing?
The radius of
The radius doesn't. The height changes as we drain this water out of here, but the radius of the water stays the same. So we can go ahead and plug in the radius. What was it? 10. Okay, so pi times 10 squared. The height is changing. The volume is changing. Let's make this 100 pi h. Okay, now that we've plugged in the things that aren't changing, now we're going to take the derivative. So what's the derivative of v? dv dt. And over here, 100 pi h. What do you think that's going to be?
100 pi.
100 pi times dh dt. Okay, so dv dt. Ooh, I also need to be careful on this problem. The water level's going down and it's draining, so we might have some negatives in here. Is the volume going down or up? Of the water. Down. So I need to plug in -3 for volume. We are trying to find dh dt. Okay, so just divide by 100 pi. And -3 over 100 pi. What do we think the units are? We're talking about the change in height.
Centimeters per second.
Yes. There's one other thing in this problem. It said how fast. So what do I need to change about my answer? Positive. Make this positive. So really it's 3 over 100 pi centimeters per second. All right, number 3. A hot air balloon rising up from a level field is tracked by a rangefinder 500 feet from the liftoff point. At the moment, the rangefinder's elevation angle is, there should be a pi over 4 here. It did not print. The angle is decreasing at a rate of 0.14, or increasing at a rate of 0.14 radians per minute. How fast is the balloon rising? Okay, so we need to draw a picture. We've got a hot air balloon rising up from the ground. I'm just gonna draw a balloon. I don't know how to draw a hot air balloon. There's a regular balloon. And it's going up from the ground, so let me draw its path right there. And then there's a rangefinder 500 feet from the liftoff point. So I don't know, somewhere over here, I don't know what a rangefinder looks like. I'll draw that. What shape are we getting here?
Triangle.
Yeah, a right triangle. There we go. Okay, there's lots of equations we could get with right triangles, so don't assume it's Pythagorean theorem or whatever. Let's start like looking at what they gave me. So the rangefinder is 500 feet from the liftoff point. So this distance right here is 500. Is that distance changing? No. So that 500 I can plug into the equation right away. At the moment, the rangefinder's elevation angle, this is the elevation angle right there. I'm going to call it theta. That is pi over 4. And you can put a theta equals pi over 4 over here if you want to. Is that going to be changing?
Yeah.
Yeah, because this balloon is going up and down, so the angle is changing and this distance over here is changing. So this over here, let's just call it h. Okay, so we have an angle and two sides. How do you think we could come up with an equation to relate those?
Right.
Yeah, sure. So what sides do I have? So what is that? Yeah. So tangent theta equals h over 500. Okay, so let's take the derivative. What's the derivative of tangent?
Squared.
Yep. So secant squared theta times d theta dt equals, please don't do quotient rule for this. This is the same thing as 1 over 500 times h. So it'd be 1 over 500 times dh dt. All right, now we can start plugging things in.
So I was trying to take it wherever somebody will put DHDT.
Yep. Whatever the variable is. So d theta dt, dh dt, whatever. Okay, what's theta?
5, 4.
Yep, pi over 4. So secant squared of pi over 4. We know d theta dt. So that's the 0.14 radians per minute. And I'm solving for dh dt. That's what I'm solving for. All right, so you could use a calculator to solve this, but I don't think it's actually that bad. Because the secant of pi over 4, let's see, what's the cosine of pi over 4? Root 2 over 2, so the secant of pi over 2 is root 2. Root 2 squared would make this 2 times 0.14, and I'm going to multiply by 500 on both sides to get dh dt by itself. So let's see, that's 1,000 times 0.14, so 140. And what are my units? We're talking about how fast the balloon is rising.
Feet per minute.
Yes. Okay,
When you plug the 2014 into what?
d theta dt. Because it's, a lot of times I'll just look at the units. Radians per minute, that's the angle measure changing. All right, I'm going to do this last one with you, and then I'll let you guys try number 5 on your own. A driveway perpendicular to a road leads to a farmhouse located 1 mile away. Okay, let me draw a farmhouse. There's my farmhouse. There's its driveway. And it is perpendicular to a road. A car travels past the farmhouse. Okay, so the car is going this way. Here's my car. Can't draw a very good car. What shape does this look like? Another right triangle. Okay, so we might be using trig. Let's see what they give us. How fast is the distance between the car and the farmhouse increasing when the car is 3 miles past the intersection of the road and the driveway? I didn't see anything about angles in there. They're just talking about the 3 different sides of the triangle. Do we know, let's see, if this is the car driving this way, is this distance changing? Who's going that way? Yes. Is this distance changing? Yes. What about this distance? No, this is the driveway. I'm going to go ahead and write 1 mile over there. So what equation can we use that relates the sides of the triangle? Yep. Well, let's do A, B, C. A squared plus B squared equals C squared. You guys said the driveway distance isn't changing, so I'm going to plug that in now. So 1 plus B squared equals C squared. Now we can take the derivative. What's the derivative of 1? 0. Okay, so we're going to go to the B squared. That would be 2B times dBdt equals 2C times CBT. All right, now we just got to plug everything in and then solve for what we have left. A car travels past the farmhouse at a speed of 60 miles per hour. That's a rate, so I know it's either dBdt or dCBT. What do you think?
dBdt.
Yeah, because this is the car going that way, going 60 miles an hour. So 2, let's see, I'm going to plug in the 60 right there. How fast is the distance between the car and the farmhouse increasing? So this is what I'm solving for, is dCBT.
Wait, do you get rid of dB when you, or 2b when you do that?
No, I haven't plugged in the value for it yet. The car is 3 miles past the intersection of the road. So where do I plug the 3 in? Yep. Okay, now I just need to figure out what C is.
Wait, why would you have 3?
It says the car is 3 miles past the intersection of the road and the driveway. So this is changing, but they're saying at the instance when this is 3. So how am I going to figure out what C is?
Divide by 2.
Nope. I'm trying to solve for dCdt. I need to figure out C so that I can solve for that.
Wouldn't just be the original?
Do the Pythagorean theorem. If you want to make a little triangle out to the side, I know this is 3, this is 1, so what would C be? Yep. There we go. Here, I'm just divide by 2 on both sides. So 180 over root 10. And what would my units be? The rate.
Miles per hour.
Yep. There you go. Okay, you guys look at number 5. See if you can read it, draw the picture, set up the equation, plug in anything that doesn't change, and then do the derivative, plug everything in. Did I grade yours in red? Wait, it's not. Yeah, I'll move this up. Okay, actually, I'm going to talk about something. I agree that the word equal to has College,
makes it more awkward.
I know, College Board said this one is true. This one right here, F prime is used this. Remember, critical values happen where the slope is 0 or above. Yeah, so it actually doesn't have to.
Okay, that's what I did. I didn't, this one, so I didn't think.
You
that
put
was
A
wrong.
originally,
No,
yeah.
I put C originally, because I thought that one was wrong.
That one is others. Yeah,
So.
so you understand this one now.
Yes.
This one, I don't know. So,
Change this?
yeah, just fix it and I'll give you the point, but I'm still. That's great at the end, okay. And then let's see. Oh. Okay, so you did that. Did you do? Oh. There. Okay, so again, it's where it equals 0, but there's actually another critical value. Because x to the negative 1/3 is 6 over x to the 1/3. So there's another critical value.
Why did you start this with six part of it? Six part of it.
For those two. So this one, okay, so what's the derivative? You got 6. Negative 1/3 plus 3. So you set that equal to 0 and find a critical value, but that one actually doesn't give you that. I think that's not. Okay, so this is 6 over. So what number could I plug in for x that would make this undefined? So check. That one should fit in.
You have to do this.
And then,
This, but I think, like, was I just missing? Like,
okay,
this?
you don't need to give me this.
Oh, I don't?
Yeah, that's what I just wanted you to just give me, like, it says when, so just say t equals 2 and 5.
And then.
Oh, and when is always just time, so it shouldn't be. And what did you fix?
This just what it was.
How fast, this is, you use velocity equation, not acceleration.
There's no way to.
So this is.
Yep, just give me t value.
You're on my.
You start new work for two.
Seven is one.
Oh, thanks. Okay. You three, I have your quizzes here. I have not put a number grade on it. I have put a star next to something you have done incorrectly. And I'm gonna let you correct it right now. There you go. That's your present. Oh, I should have done this problem first. Oh, well, I'll let you guys work on the quizzes first. Okay, and then I need to check yours.
Yep.
Okay, so you corrected everything on
Yeah.
text? Good. So, okay. And then you just have to do that similar problem. That's due Wednesday. Let me, check your quiz. You have to use the velocity equation. You gotta use the velocity equation for E also, E and F. That's right. Z is not. I mean, if you wanna correct it, you have to go. Oh, did you get everything right? Good job. You can keep that. Okay. You have a red or blue. Yeah.
I figured out some of this with some of our.
Let's see. So number 9. Yeah. This one, do you understand this one?
I mean, I crossed off A and B, and I previously circled C. I just didn't.
Okay, so relative extrema would be when this, if this is F prime, it's where it goes from positive to negative or negative to positive. So there's 1 here. This is actually 1 because it goes from positive to negative, even though it's not defined here.
Yeah.
So 1, 2, 3. Those are the relative extremes. The points of inflection, that's where it goes from increasing to decreasing or decreasing to increasing. So there's 1, this one was where it's tricky because it goes increasing and decreasing. So there's 1 here, 2, 3, 4.
I got those last 3.
Okay, it is. Okay, so you need to find the derivative of this instead of equal. So, the
Oh,
first
sorry,
one.
no.
This one's not.
That means I got like
Okay, this one,
like a 7.
it's fine. This one, because I'm gonna.
Okay, sorry, yeah.
Okay, number 4, you gotta show work. So
Yeah, that's the one I.
this is right. Okay, so these are all right. So
Where's your work under?
critical point. How do you find a critical value? Yes. Okay, so why don't you do that first? So you need to do product x squared times e to the kx. Oh, you have it here.
Yeah, so I did that, but that's just in.
Okay, so can we factor out an e to the kx?
And that didn't see his pouch.
Yeah, so e to the kx. 2x plus ax squared. Okay, there's no way that this can.
It's not.
Now set this equal to 0, plug in 2/3 for x, and solve for k. You got a question?
I have a question on the first one. What's that?
Okay, so 2a, 2c. Are you sure you did it wrong? The answer keys are the front. I think that is right.
Which one?
Yeah. But make sure you do 3 decimal places.
No, no. I think the next one was 0.
Okay, so you still have to write the 0, just so you know.
Thank you.
Yeah.
Wait, how do I solve this?
So 2x plus kx squared equals 0, but plug in what they say x was 2/3. So plug in the 2/3 for x.
Okay, so I use the velocity equation.
Yes,
And this one.
correct. Okay,
And then.
no, I'm fine. This one, you have to use the position function. You could use your calculator. If you could type this and divide 1.
What is one of those?
I don't know, it's not the right number, so I don't know if you type that or not.
And then.
Acceleration was the slope of the slide size. Yeah, so right. So we went down 0.1. You like added them together and divided by 2. Rise over run, so down.
Oh.
0.1.
Okay, I was doing the math.
Oh. You right over run.
Farthest on unreal.
So it's.
Very, very good.
And then that was.
So you see where you made that one in. Yeah, but, and I signed the other ones. But here, let me sign that. Even though your work is on, that's fine. Okay, so you got, is that all of them? You didn't, you don't have work for this one.
Yeah, wait, how do I do that? I said that the
Yeah, you need to do the motion. Okay. All right, I'm gonna go over this one real quick, guys. Did we figure out the picture? They're wrong?
Like on the board, like on that.
Oh, I know. I don't know. Okay, so we had convoy A goes east. Convoy B goes north. So A, B. And let's see. What equation did you use for this one?
A diagram.
Yeah, it was relating the sides. Plus C squared equals C squared. Is anything staying the same on this problem? We had this truck going that way, this truck going that way, the distance between them is changing, so I'm just gonna take the derivative. 2a times dA dt plus 2b times dB dt equals 2c times dC dt. If you want to, you could divide everything by 2 and get rid of the 2's right off the bat. And then you just had to plug in the right numbers, so let's see. A was 5, and A's speed was 50. B was 6, truck B's speed was 60 miles an hour. And you had to do a little Pythagorean theorem to figure out C, which was root 61, and we're solving for dCdt. So add that up, divide by root 61. So 610 over root 61, or you could make it 78.102. And this is miles per hour. How'd we do? Did you get it? All right, so yay, you have no homework now.